Multiplexer and demultiplexer are exactly opposite in nature. In case of multiplexer, there are many inputs and only one output. In demultiplexer, there is only one input and many outputs. Multiplexer can be used in parallel to serial conversion because many inputs are there and a single output is there. In demultiplexers, through single input, many signals come and they are converted to parallel form. In the transmitter section, many signals are combined together and sent along a single signal line using multiplexer. At the receiver end, many signals come along a single line and they are separated using demultiplexer. Now let us see what is demultiplexer. Demultiplexer is one to many. That is one input and many outputs. So if we draw a block diagram of demultiplexer, then it will be one to any demultiplexer. It has only one input. Let us call this input as D input. And the outputs can be multiple. So this will be suppose Y0, Y1 up to Yn are the outputs. To select that data will be sent to which output, for that there are signal select lines. These are the select lines. Select lines can be 1 to M, suppose select lines S1 to SM, select lines. When there are M select lines, 2 raised to M is the maximum number of output lines. So N is always less than or equal to 2 raised to M. So if there is single select line, then there can be 2 output select lines and outputs. If there are 2 select lines, there can be 4 output. 3 select lines, there can be 8 outputs. 4 select lines, there can be 16 outputs. This is same as in case of multiplexer. Now let us design 1 to 2 demux. 1 to 2. So there is only a single signal line. So only one select line will be. So if we consider input is D. If we consider select line, suppose select line is A can have 0 and A can have 1, value 1. And outputs, now there are 2 outputs, Y0 and Y1. If A is equal to 0, then this D will go to Y0 output. At that time Y1 will be 0. And if A is equal to 1, then D will come to Y1. At that time Y0 will be 0. This is. As there are 2 outputs, there will be the circuit is more simple than multiplexer. There are 2 AND gates. This AND gate will give output Y0. This AND gate will give output Y1. The signal D will be connected to both the AND gates. So this is D. Now this is a control signal. This control signal will be connected to Y1 directly because when A is 1, Y1 is getting D and it will be connected through inverter to the first AND gate. So this will be A bar here. So Y0 we can say that D dot A bar and Y1 we can see that D dot A will be the equation of this. So this acts as demultiplexer. D signal goes to either Y0 or Y1. It depends upon the value of A. A is a select line. Now the similar line we can extend it to 1 to 4 demultiplexer. When it is 1 to 4, naturally select lines will be 2 select lines. Let they be A and B select lines. Now what we can decide is input is D. Select lines are B and A. Outputs, there will be 4 outputs because it is 1 to 4. So Y0, Y1, Y2 and Y3 are the 4 outputs. Now D input is continuously provided. When there are 2 select lines, there will be 4 combinations 0, 0, 0, 1, 1, 0 and 1, 1. Each combination will select that the D input will be provided to which output. So when it is 0, 0, D is provided to Y0. At that time other 3 will be 0. At 0, 1, D will be provided to Y1. Other will be 0. When 1 0 it is provided to Y2, and when 1 1 it is provided to Y3. So in this way each of the output will get the D signal, and which output will get the D signal, it is selected by the select lines. Now let us draw the circuit. The circuit is again very easy. 4 AND gates for 4 outputs. 4 AND gates for 4 outputs. This will generate Y0, this will generate Y1, this will generate Y2, and this will generate Y3. The input D will be provided to all the gates because it should reach to all of the gates. So input D is provided to all of the gates. Now observe that Y0 will get the input signal when the condition is A and B 0 0. That means A bar B bar. That is the condition is A bar B bar. So Y0 is D A bar B bar. Because when A and B both are 0, A bar and B bar is the main term. Now Y1 is B is 0 and A is 1. So Y1 is equal to D A B bar. Y2, now Y2, B is 1, A is 0. So Y2 is equal to D dot A bar dot B. And Y3, when both are 1, so D A B. So naturally the AND gates should have 3 inputs, and the inputs will be given from the select lines. Now let us consider the select lines are this. Suppose this is B and this is A. So B is here, A is here. Now let us use inverter to generate B bar and A bar. So this is now A bar here, this is B bar here, this is A and this is B. Now let us connect. For the first AND gate, A bar and B bar are connected. So this A bar will be extended, it is given. B bar is extended and it is given. Now for the second, D, A and B bar. So A, sorry, for the first case, this was A bar. Now this is A and B bar. So A is connected and B bar is connected. So this is a connection here, B bar. See, though there is a crossing, the lines are not connected. Whenever the dot is shown, only that places the lines are connected. D, A bar and B. So here A bar will be connected. This A bar is extended here and B is connected here. So B will be connected here. And this case A and B. So this A is connected and B is connected. So this way we get the circuit of 1 to 4 demultiplexer. On the same lines it can be extended for 1 to 8 line multiplexer. For that there will be A, B and C 3 select lines. 1 to 16 demultiplexer, it will have A, B, C and D 4 select lines. This demultiplexer circuit also acts as decoder if the input signal is absent. The demultiplexer circuit also acts as decoder if the input signal is absent. So let us try to understand what is decoder. Decoder and encoder is a pair of circuits. Encoder generates the code and decoder finds the meaning of the code. So decoder always has less input lines and more number of output lines, and it codes the input signal and generates the desired output. So decoder can have 2 input lines, then it can find out the meaning for 4 outputs. 2 to 4 line decoder, or 3 to 8 line decoder, or 4 to 16 line decoder. It can also be BCD to 7 segment decoder. It can be always BCD to decimal decoder. These are different types of decoders. Now let us consider here first 2 to 4 line decoder. So if we consider 2 to 4 line decoder, then there will be 2 inputs and 4 outputs. So the same demultiplexer circuit, if we call A and B instead of select lines, if we call them inputs, A and B are inputs, then at that time the outputs are either in the form of 0 or 1. Then when input is 0, 0, only Y0 is 1, all others are 0. When input is 0, 1, only Y1 is 1, all others are 0. 1, 0, Y2 is 1, and 1, 1, Y1 is 1, because data is not there. So one of the 4 output is selected by the input signal. Input signal is in the form of a code, and the code is decoded here. Decoder has many applications. Now in the same circuit, if you consider that only the D part is totally deleted, and here also the D part is totally deleted, then we get this type of circuit. This circuit is 2 to 4 line decoder. This circuit is 2 to 4 line decoder. And this decoder will have this as truth table and this as the circuit. Depending upon the condition of A and B, when 0 and 0 is the case, at that time this will be 1. Then B is 0. Sorry. This is A bar and B bar. So when A and B both are 0, this will be 1. When A and B are having 0 and 1, then Y1 will be 1. Because if A and B both are 0, A bar and B bar will be 1. When A bar and B bar are 1, this is 1 and this is 1. Both 1, 1, this output will be 1. At the same time, here A is connected, which is 0. For this circuit, B is connected, which is 0. Here A and B connected, which are 0. So outputs of all other AND gates are 0. Only one of the output is 1. This is the working of the decoder circuit. Similarly, on the same lines, we can have 3 to 8 line decoders. We can have 4 to 16 line decoders. The decoders are very much important circuits in memory allocation in computers. Large amount of memory is there. This memory is separately allocated to different specific applications using the decoder circuits.